Hello everyone, my name is Horace, and in this video we're going to be going through LeetCode number 152, maximum product subarray. For this problem, we're given an integer array nums, and we have to find a subarray that has the largest product, and then we simply want to return this product. And the test cases are just so that it fits in a 32-bit integer, and we can keep this in mind when thinking of a solution. Okay, let's take a look at this example of an integer array nums. So we have various different elements, and they can either be positive or they can also be negative, but we're guaranteed that they will be integers. So we know that if we traverse starting from the beginning of the nums integer array and we traverse it, then we're going to get an increasing sum. Granted, if there's no 0, because that will just negate the sum to 0. But we can be assured that there will be nothing like 1/4, which will divide the current sum in a quarter. So that means we can kind of approach this by starting at the beginning of the nums array and move towards the end. So what that will look like is we can take a look at the first element, and currently the largest maximum product subarray is just a value of 2. But then we can also look at these two elements. So this is going to be 2 times 3, which is 6, and this is definitely larger than the 2 value. So this is the new maximum product subarray value because we're going to be returning an integer. So we can say that at this point 6 is the maximum. Then we can take a look at this subarray. Well, now we have 2 times 3 times -2, and this is going to be -12, which is definitely less than 6, so we don't need to update this value. And then finally, we can take a look at the subarray which contains all the elements. So in this case, we have 2 times 3 times -2 times 4. And this is going to be -48. And this is still less than the 6. So in reality, this is the largest maximum product subarray value that we'll be returning. Okay, now let's take a look at this example and use the same approach that we did for the other integer array. Well, if we start at the beginning of the array, we see that we have -2 and we don't have any other elements. So currently, this is the maximum product subarray value. So then we take a look at the next element. So -2 or -2 times -3. And since these are both negative integers, they become a positive. So we get +6, and +6 is greater than -2. So the -2 is going to be replaced by the 6. Then we take a look at the entire subarray. Well, we have -2 times -3 times -4, which is going to be -24. And this is less than 6, so we don't update it. But is this the correct answer? Well, clearly 6 is not the correct answer because we can find a subarray, in this case -3 times -4, which is going to give us 12, and 12 is greater than 6. So we've found a counter example, and that means this approach is not correct. So what can we do to fix this approach? Well, we saw that this value is affecting whether or not the output is going to be 6 or not. And this is all dependent on its sign. So what if we keep track of the minimum and maximum values so that whenever we find a negative value, we can simply just take the maximum of them. So what we can do is we can keep a minimum and we can keep a maximum, and these are going to be updated whenever we multiply the two consecutive integers or the product. So at this point, the minimum value of -2 and 3 in this subarray is just going to be -3. That is this subarray by itself. However, the maximum is going to be the product of -2 and -3. So this is going to be 6 at this point. Then we can continue with the next operations, but we can just use these values here that we calculated and multiply it by -4. So we see that the minimum value, -3 times -4 is going to be 12, and -4 times 6 is going to be -24. So we see that -24 is going to be the minimum value, and 12 is going to be the maximum value. So at this point, we're keeping track of both the minimum and maximum values that we can get depending on the negative sign. And if this was a positive, these would just be multiplied by some positive constant, and it would just change the magnitude, and it wouldn't really change the sign. But as you saw, these two were kind of swapped over depending on the magnitude and the sign. And then we can keep updating the maximum, and in this case it is 12, so we can just return 12 at the end. And the time complexity for this algorithm is just going to be big O of n, since we're just traversing the array one time. It's a one pass approach, and the space complexity is also going to be big O of 1, since we're just using integers to keep track of the minimum and maximums. We're not using any arrays or hash maps. So with that being said, hopefully this approach was clear and we can write the code on LeetCode. Okay, so we can start writing the code on LeetCode. We can begin by initializing a max and a min products, and we'll just set this to be the beginning of the nums array. So we'll just say like max product currently is going to be nums at the first element, and the min product is going to be nums 0. We can also keep a result, which is going to just be the max product in the beginning. Then what we can do is we can iterate from the first element all the way until the end. So we can write a for loop, and we can actually just start it at 1 since we've stored num0, and it will return the maximum product anyway. What we can do is we can check if a element is negative, and if it's negative, then we know there's going to be a swap in the minimum product and maximum product, and that was kind of what we saw in the explanation as well. So we can check to see if the element is negative. So if it's less than 0, then we're going to swap the maximum product and the minimum product. Then what we want to do is we want to update the maximum product and the minimum product. And the way we want to do that is we want to either check if the element itself is a maximum, or if the max product times whatever the element is the max product, or the min product times whatever element is the min product. So what that's going to look like is max product is max nums I. So this is just the element itself. So let's say if we have like 1, 0, 2, 2 would be by itself since this would be 0 before it. Or we have basically the max product, what we previously had, times whatever element it is. And then we can do the same thing for the minimum product. except we just have to change it to the min product here. And then what we can do is we can update the results to be the maximum of what we currently have or the max product, since we're always wanting to keep the maximum value. Then finally, we can just return the result, and this is the solution. It's quite straightforward once you understand this swapping that's taking place, as well as keeping track of the maximum and minimum. Okay, we can try and submit this and see if it's accepted. And looks like it's accepted, and we can see the code here. It runs in big O of n time and has big O of 1 space complexity, because these are just integer pointers and no hash table or other arrays are used. So with that being said, hopefully this video helped you and you learned something, and I'll see you soon.